Today we are going to do section 9.2 on page 912, which we're going to talk about something that's called the law of cosines. The law of cosines says that if we have a triangle, which I drawn one here, okay, that's identical to the one that's in the book. If we have a triangle that has sides A, B, and C, then this equation satisfies. That is, a squared will be equal to b squared plus c squared minus 2 times bc cosine of alpha. Alpha is the angle that faces A. Okay, your book calls it theta, but I call it alpha because alpha is the first letter in the Greek letter, so it corresponds to A in a nicer way, and I feel that might make it easier to remember. But the alpha here is the same as the theta in your book. Okay, but everything else is the same. So now, if this is the case, then if in this situation, then this is the law of cosine. The law of cosine, as you can see, is similar to the is similar to the Pythagoras theorem, except that it has this extra part. Okay. Now, if in some cases, then it actually does. Well, doesn't matter in what case. We don't care about that right now. Okay, so that's let's just prove the law of cosine for the moment. The book has given a direct proof of the law of cosine, so we will figure out what this means. So looking down a little bit, okay, we have a point C. That's the point on top, and this distance all the way here will be called x, and this distance up here will be called y. Specifically, the coordinate of the point C will be given as will be b cosine alpha. Okay, that's this distance, right? B is the hypotenuse, so b cosine alpha will be this distance. So let's write that down: b cosine alpha, and then the vertical distance will be b sine alpha for similar reasons, and then b sine alpha. That would be the coordinate of C. I mean, that's one way to say it. The other way to say it is just call it x comma y. But we're going to call it this way for a reason. And then, what is the next thing we're going to do is let's look at this. Then a squared, using the Pythagoras theorem in this triangle where this is a right angle, and then this is. And the Pythagoras theorem says that a squared, that is the hypotenuse, is equal to x minus c squared. You know, this part squared. This part is x minus c, so we'll call it x minus c squared. Why do we have two c's? I don't know why we have two c's. And that's the big C and that's the small c. Okay, so but we're not going to use the big C. So in fact, let's get rid of it so that it doesn't confuse anybody. There. So the point is, this point here, the coordinate of this point is b cosine alpha and b sine alpha. I'll draw the point a bit bigger. There. So considering this little triangle that is a right angle triangle, applying the Pythagoras theorem, then a squared will be x minus c squared plus y squared, because the vertical distance, we'll call it y. In other words, this is x and this is y. Okay, and so plus y squared. I'm just following exactly what your book is doing. And so the next step is, of course, and that will be equal to x minus c is and well, we know what x is. X is b cosine alpha. Okay, they're the same thing. So we'll substitute that in. Replace x with b cosine alpha. We'll have b cosine alpha minus c, and then squared, plus y is b sine alpha. So we'll write that down. Y is b sine alpha, and then squared. So now we're down to the second line. So far, so good. And that, of course, can be expanded. And after the expansion, Now please do the expansion yourself, okay? Because it is as written here, but you can totally do this like algebra homework. So squaring this thing will get b squared cosine squared theta, that's the first term, and then c squared, that's the last term, and then 2 times this one and this one. So it will be 2 times bc times 2 times b cosine theta times c. And also there's a negative sign there. So that is how the second line will be come out with. As to this part, that's just b squared sine squared theta that comes from that. So each one got squared. So the next step then, now that we have done that, let's see, we will do certain substitutions. Let's see, 2bc cosine theta, okay? Let's see what that is. Oh, oops, now give me a second here. So the next step is that we're going to play a useful trick. That is we're going to move the minus bc cosine theta to the end of the equation and move the b squared sine theta up here. Why? Because we're going to use a factoring trick. So now we have b squared cosine squared theta and b squared sine squared theta. So let's factor out the b squared. So then we have ended up with cosine squared theta plus sine squared theta. Now that is going to be cosine squared plus sine squared equals to 1. Okay, so that knocks them out. So we only have b squared left for this part. Now in the meantime, c squared minus 2bc cosine theta is still here. Okay, and we keep it. So then what do we have? We started out with a squared. So the whole thing ended up being a squared equals b squared plus c squared minus 2bc cosine theta. And that is what I have up here, except I call it alpha because I feel that might be easier. And but you can call it anything you want. It's just the angle that faces A. Okay, that's the part that you need to remember, is that in any triangle, the law of cosine states that one side, okay, it doesn't matter which side, we'll call that the first side, we'll call it A, and that squared will be equal to the other two sides squared, okay, and then minus the 2 times the other two sides, and then times the cosine of whatever this angle is that's facing A. That's very critical, okay? Not just some random angle. You cannot plug in just any of the 3 angles. There are 3 angles in the triangle, and only the one that's facing A in this equation is the one that can fit in, that you can put in here. All right, so that is that. Now the law of cosine can be written this way or some other way. That is, you can write it in terms of B or in terms of C. But that really just depends on what are you calling ABC, okay? And so law of cosine actually just have one equation. The others are just changing names of things and a bit of a waste of time, in my opinion. But if it's helpful to you, and by all means look at it. Okay, but just the very first one is the one that you need to remember. The law of cosine is quite important, and it's going to be used in calculus and beyond. And so it is pretty good to memorize it, or almost memorize it. That is, if you ever need to use the law of cosine, then you know exactly where to find it. You know it's roughly something about a squared, b squared, something, and. But anyway, but when it comes to memorizing, then for sure you only need to memorize one. Okay, just remember what these symbols mean, and that what the critical point is A has to be facing alpha, or alpha has to be facing A. Otherwise, you got the wrong angle. And so let's do some examples to see what's happening, okay? Oh, by the way, let's look at the next page, 913. Because we have this equation, we can also solve for cosine alpha and get a bunch of stuff. If we solve for the cosine alpha in terms of the other things, then we get an equation that looks like this, okay? And that the cosine alpha can be easily solved. You can do this in one step. By just looking at this thing, cosine alpha would be a squared, okay, minus b squared, throw it over there, minus c squared, throw it over there, and then just divide it by everything here, including the minus sign. And And that's how this formula came out. Anyway, so that's that, and let's look at example 1 on page 913 and try to do something with this fancy piece of information that we just learned. Now let's look at example 1 on page 913. We have a triangle here where okay, here's my triangle. The one side is 10, another side is 12. We need to find out what this side is, but we do know that this angle equals to 30 degrees. So then, all right, so let's see what we can do. First, let's use this thing that we just learned. That is b squared is going to be equal to the other two, 10 squared plus 12 squared minus 2 times 10 times 12 and cosine of 30, okay, according to the law of cosine. So let's do that. So I'll write that down according to this formula right here. B squared, okay, is remember the angle is whatever angle that faces B. That will be the alpha here. So B squared equals to the other two sides squared. So 10 squared, that's 12 squared, whatever, 10 squared, that being added, minus 2 times 12 times 10 times cosine of 30 degrees. And that will give us B, okay? We just need to do this and then take the square root, then we're good. And so now once we have B, the next step is we have to find out what these two angles are. And then let me see. Yeah, so then we can use the law of sine. See, the law of sine says that each side divided by the angle that it faces is going to be equal to a different side divided by the angle that side faces. So then we can calculate these things. Now b divided by sine of 30 is going to be equal to 12 divided by sine of gamma, okay, according to the law of sines right here. So 12 divided by sine of gamma, being that 12 faces gamma, and that equals to 10 over alpha. For the same reason, 10 over sine of alpha. All right, so these equations will enable us to calculate all the stuff. Okay, then so what's left to do here is just to pull out the calculator and crank it all out. So first, let's do B. So to calculate B, we need to first turn on the calculator. Okay, that looks okay. And then let's type in the square root. Okay, we're going to start with the square root of that entire list of stuff. Square root of 12 squared plus 10 squared. We know it's 100, but we'll just type it in. Plus, minus, delete, minus, no, that's not minus. This is minus. My calculator makes a difference between the negative sign and the minus. So if your calculator does that, then you just have to be careful about that. So minus 2 times 12 times 10 times cosine of 30, close parentheses. That should be it. Okay, let's see if it equals anything. Okay, it equals 6.01. And let's see what the book says and see if I got it right before we go forward. And okay, let's see, next page. B is 6.01. That is correct. All right, so far so good. Okay, and so we have B equals to 6.01, and then that's that. And the next thing we have is we need sine of gamma and sine of alpha. So let's do that thing that we've been doing since in the last section. That is, move sine of gamma up here. So sine of gamma is going to be equal to, move that up there. So the equal 12 is still here. Move the b down. Okay, b equals to 6.01. In fact, I'll just write it like this. And then and the sine 30, we'll move it up here, times sine of 30 degrees. In other words, gamma is the sine inverse of all the stuff. Okay, so gamma equals to let's calculate that. So then gamma is arc sine or sine inverse of 12 divided by 6.01, and then times sine of 30, sine 30 there, and that should do it. That gives us gamma equals to 86.69 degrees. All right. So gamma is 86.69. Let's see if we have that somewhere. Gamma. No, they have gamma at 93 degrees. I wonder if I might have made a mistake in here somewhere. All right. Well, we will worry about the gamma later. Okay. And let's try to do. Let's try to calculate alpha. Let's see if so similarly sine alpha, and then I'll check to see where I messed up on gamma. So sine alpha, in a similar way, move sine alpha over here, and then the b goes to the bottom. So 10 over 6.01 times well, we can also do the 180 degrees trick. Okay, once we know the other angle, we can just do 100 degrees. But since my gamma is wrong, we'll just do it the law of sine way. There's more than one way to do this. And so anyway, as I was saying, to do sine alpha, we move the sine alpha up here, right here. And 10 stays, b goes to the bottom, and sine 30 goes on top. Well, the same as this one, right? So let's see where that goes. Now I got this thing 12. Let me check sine gamma again. I still have it on my calculator. 12 divided by I'll show you what I have. Sine inverse 12 divided by 6.01 times sine of 30, and I'm in degree mode, so it should be okay. Let's see. Yeah. So I'm not sure why is this different. So I will write this down, and 86.69 just to, and I'll figure out where I got wrong later. Yeah. In the meantime, then let's see. And let me fix something here. My camera got knocked out. All right, so let's calculate sine alpha. Okay, sine alpha will be inverse shift sine of 10 divided by 6.01. Okay, and then times sine of 30, sine 30, and that should be two parentheses. It should be, alpha should be 56.3 degrees. So that's what I have, is alpha is 56.3 degrees. And let me see what the book says, okay? And yeah, they have alpha equals to 56.3. So this one is correct. So why isn't the other one right? Let me just check this real quick. Actually, we can check this. I mean, there's got to be a mistake somewhere, because and we can check it easily enough if I know where I left my calculator. It's over here. All right. Now the way to check is, what is this 56.3 plus the 86.69 is equal to 142. Together is only 172. Yeah, so this is wrong. How can that be? I'll try it again, okay? Because the last angle is 30 degrees, so you add it together, that doesn't add to 180, which is not okay, which means I'm wrong, okay? And so let's figure out where I'm wrong. Try again. So shift sine inverse of 12 divided by 6.01 times sine of 30. Okay, and try again. It still says 86 degrees. Let me think about this. Maybe I'm missing something. All right, I figured out what the problem is. The problem is that this is correct, okay? That is sine of 86.69 degrees is this value. However, it doesn't suit our problem because whenever we calculate sine inverse, we have to remember that there are two of them. That is, there's one on this side and then there's one on the other side, and we have to consider which one is more suitable. And in this case, the one that's slightly more than the one on the other side in the second quadrant is actually the right answer, because this one won't fit, okay? And because gamma is b is only 6, okay? B equals 6. Gamma faces the longest side, so gamma should be the largest angle. And then so alpha makes sense that alpha is 56 degrees, because the other option would be 180 minus 56, that make it too big. But this one doesn't work, so we need to take 180 minus 86, which is the 93 degrees that the book has, okay? And or we can just use 180 degrees minus 30 degrees and minus the 56 degrees for alpha and do it that way, which is what the book did. Anyway, so all this works out for example 1. And which is why the book calculated alpha first and then did the 180 degrees minus the other two angles. So then we don't have, so that they don't have to worry about why this gamma's value isn't working out, because we have to pick the slightly bigger gamma and for the angles to add up to be 180 degrees. So anyway, that's example 1. And next, let's look at example 2. So next, let's look at example 2 on page 914. We are supposed to find the angle alpha. Alpha is the angle that faces side A, if with the given values. Okay, A is 20, B is 25, and C is 18. So let's write that out. So A is 20, filling in this formula right here. A is 20, so we have 20 squared equal to B is 25 squared plus C is 18 squared minus 2 times 25 times 18 times cosine of alpha. That should do it, okay? And from this equation, then we can figure out what alpha is. Alpha then equals to that thing subtracted by that, okay? And then subtracted by that, and then divided by all this stuff, and then taking the inverse cosine. So let's we can write it out that way. So then what are we doing? Okay, we're trying to calculate alpha. Then alpha will be equal to the inverse cosine of 20. Okay, we started at 20 squared. Throw the 25 over there. That'd be minus 25 squared. Throw the 18 over there, and then minus 18 squared. And then, okay, so all that got tossed over, but that's not all. Then we need to divide it by the negative of 2 times 25 times 18. And yeah, and then we take the inverse of cosine. That should do it, okay? And that's that. So let's pull out the calculator as soon as I find it. There it is. And figure out what this thing is. So the answer then is shift cosine of 20 squared minus 25 squared, and then minus 18 squared. That is so I have written this stuff, but I need more parentheses. So I need to go back and put in more parentheses, because I have a division here. So all the numerator has to be inside parentheses. So I move back, okay, I moved back to where my cursor was, and then add another parentheses, and then I get back out, and so that I have enough parentheses. Come on, keep moving. Where am I? Oh, I got to the beginning. Okay, that's the end. So then now I can do the close parentheses. Okay, and then do the division. Divided by parentheses negative. Okay, so I have divided by, and then denominator I will also put it in parentheses to be even though well, yeah, just to be clearer. divided by negative 2 times 25 times 18, close parentheses, and then close parentheses again. Okay, the first parenthesis, close parentheses, is for the fraction. The second one is for the cosine inverse. So that should do it. I got 52.4 degrees for alpha. Okay, so that should be it. Let's see, that's example 2. Oops, I lost the book. Let's see, flip to the other side. Alpha is 52.4 degrees. Okay, that's exactly what I have. So far so good. Next. So next, let's do example 3 on page 915. So next, let's look at example 3 on page 915. We have, in this problem, we have two cell phone towers that are 6,000 feet apart. They're going east and west like this. And then there's a cell phone here that is 5,050 from the first tower, and then 2,420 from the second tower. So now we have, basically we have a triangle that we know all three sides. The question, what are we looking for? We need to figure out what this distance is. Okay, we'll call that distance x. I think that's what the book calls it, maybe. Yeah, that's what the book calls it. So we'll call this distance x, and then this distance y, and this is a right angle. So x only goes all the way to here, where we have a perpendicular line. So then that is the distance of the cell phone east of the tower and north of the tower. Okay, and together it makes the 550 in a straight line. But if you were to go this way, from the tower, you have to go west or east or wherever. What is that? East? Well, whatever. You have to go horizontally by x, and then vertically by y, and then you get to the cell phone. So the x and y are what we're looking for here. Now, to look for x and y, the first thing we need to do is figure out what this angle is. We'll just call it theta, because that's what the book calls it, which is okay. And then theta will calculate it exactly how we did example 2. Okay, so theta will be equal to the cosine inverse of all the stuff. And let's see, the side that is facing, that is the A. Okay, so the cosine inverse of, actually maybe I should just show you the formula in the book so that you know what I'm, instead of working this out, because the book did give us the formula, right, a couple of pages ago. And if we can just find it, my page refused to turn. Where is cosine? Yeah, the cosine of the angle equals to the side. All right, here it is. Okay, here's there's 3 of them, and we only need 1. So cosine of the angle is the other 2 sides minus the side that it faces, and then divide by the other 2 sides. So the cosine is the angle then equals the cosine inverse of the. So here's the angle, and the 2 sides that's next to the angle are the ones that we'll do the square of and add them up. So we will have 5050, that's squared, okay, plus 6,000, that's also squared, and then minus the side that it faces. Okay, so alpha faces A, so we're minusing what the side it faces, which is the 2420, and squared. And then the whole thing will be divided by 2 times the two sides that's next to it. Okay, so then 2 times 5050 times 6,000. So I am following this formula here, and this formula is on page 913, just a couple of pages before, where we have where we mentioned this. That this is just the same thing as this one. Okay, I was basically drawing this one out of there, but let's not do that again. We'll just use the formulas that's already done. And so now we just have to pull out our calculator and get that to come out and not type in anything wrong, and then we will be doing great. Okay, so I will stand here. That sort of block your view, doesn't it? Either way, it's going to block your view. Well, just follow maybe I hold it a little higher. Yeah, that might be okay. Anyway, so we need to calculate cosine, inverse cosine of another parentheses. Okay, this time I'm not going to forget it because we have a fraction inside. So let's put another parentheses in. So we have 5050 squared plus 6000 squared. Oops, I pushed the wrong thing. Get rid of that. Squared. Okay, and then minus 2420 squared. And then close parentheses, then divide by what's on the bottom is parentheses again, 2 times 5050 times 6000, and then close parentheses, and then close parentheses again. That's for the cosine inverse, and that should give us something. 23 theta is 23. Theta is 23 degrees. Is that right? Let me think. Let me check. Did I miss something? 5,000 and plus 6,000, right? Yes, minus 2420. I did do the square, so that looks okay. Divided by parentheses 2 times 5050 times 6,000, 2 parentheses. Yeah, that should be okay. 23 degrees. Let me see. Is that right? Let me check here. What example is that? Okay, let me find it. Actually, that's right. See, theta is 23 degrees. It's not that big. I was thinking about this angle. No, we're not doing this angle. We're doing this one. So theta is just 23 degrees, 23 point something. I'll write it down here. Theta equals to 23 times 0.33. Okay, and so once we got theta, then we can do x and y fast enough. Okay, that's what's x? X will be equal to us. Let's see, what is that? X. Anyway, x is the cosine, right? So x over 5,000 is equal to cosine theta. So x equal to the 5,000 times cosine theta. Now that we know what theta is, and then y is the same thing, except that times sine theta. So that should do it. Right? So that's what x and y is. The reason is because x divided by hypotenuse would be cosine theta, and y divided by the hypotenuse would be sine theta. All right, so let's do that. So first, let's calculate x, which is 5050 times cosine of 23.33. Close parentheses. I forgot to type in times. Let me add the multiplication thing here. Okay, that's better. So I have it right here, 5,000 times cosine 23.33. That should be right. And that gives us 4637. And let's see, does the book say what's x? 4638. Okay, that's close enough. Yeah, that's because the book didn't have only carry this thing to 1 decimal point, so we're more accurate than the book as a result. Anyway, so the other value is similar. Then we just change. We can just go back to the equation. I can go back to the equation and change the cosine to sine. I'll delete the cosine and type in sine, and that should give us 1999.9 and stuff. And well, the book has 1997.5. That's close enough. Okay, and again, because we kept more decimal places, so we're more accurate. But either way, it's the right answer, and that is that. So next, let's look at example 4 on page 916. A boat leaves port. Here's port. Okay, it traveled 10 miles, so I got 10 there. Then it turned 20 degrees, and then so I have it turning this way, and then it traveled another 8 miles. So this distance here is 8. So the question is, how far is it from the port that it started with? So we need the third side. As a result, we have the 2 sides, okay, and one angle. What's the angle? The angle will be 180 minus 20, and that makes it 160 degrees. Come on. 160, I'll write it down right here. okay, because together they better be 180. So as a result, we have two sides and the angle in between, and we need to find the third side. That is a perfect candidate for the law of sine. So c squared then equal to, following this rule, okay, so the third side will be equal to the square of the other two sides, 10 squared plus 8 squared, minus 2 times the other two sides multiplied together, 10 times 8, and times cosine of the angle that's in between them, which is cosine of 160 degrees. And that's it. So c will be the square root of all that stuff, okay? So let's do that. We will type in, first clear the calculator. We'll start with pushing the square root, so we're good to go, okay? And type everything inside. First we have 10 squared, which is just 100, plus 8 squared is 64, minus 2 times 10 and times 8, that's 160. I'm just going to type that in, and then times cosine of 160 degrees, close the parentheses. Okay, I just typed everything in because the book happens to give us some very comfortable numbers that can be easily done, as long as I don't make a mistake doing it. That would be good. So so that should be okay. So then c, I got c equal to 17.7, which let's see what the book says. Is 17.7 okay? Look at the other page. Yep, it is correct. So that's that. And now on the following page, okay, page 917, we have something called the Heron's formula, which we are not going to prove, I guess. And all we're going to do is just take a quick look at it. Okay, this is a formula that's used to calculate area of a triangle if you know all three sides of a triangle. So once you know all three sides, then you have to calculate what S is. S is the average of three sides, not average. S is all three sides and then half of the three sides added together. Okay, that is, S is half the perimeter. And once you figure out what S is, then you plug it into this formula, which is symmetrical, but there's, it follows a pattern. You start with S, okay, then times S minus A, times S minus B, times S minus C, take the square root of all of it, and then you will have your area of any old triangle you want, okay, it doesn't matter which triangle it is, as long as you know the three sides. Now let's practice using Heron's formula by doing example 5, which we're just going to do that. So example 5, okay, here it is. We have some random triangle. We know the three sides. So what's S? S will be 10 plus 15 plus 7. 15 plus 7 is 22, plus 10 is 32, divided by half is 16. So S will be equal to 16. So now that we know that, let's plug it in, okay, in the calculator. So first, let me clear that. The first thing we do is type in the square root sign. And remember, S is 16, and the formula says S is equal to area equal to S times S minus A. What's A? Is 10. That will make it 6, okay? Because 16 minus 10 is 6. All right, I forgot to multiply, times 6. And then next, S minus B. B is what? 15, so that would be 1. So we don't have 16 minus 15 is 1. And then C, S minus 16 minus 7, that would be 9. So I got all this. And that gives me the area to be, what does that say? 12 square root of 6. I don't want to hear that. Okay, 29 point something. Yeah, 29.39, which the book says 4, and that is correct. So to apply Heron's formula, you just plug everything in like it says, and then everything will come out, kind of like following a recipe. So okay, next we have let's look at example 6. Now example 6 is no different than example 5. It gives you a triangle with 3 sides, and then you're supposed to calculate the area with Heron's formula, which is fine, okay? And so please do that yourself, plugging everything in like you're supposed to, and then and that should come out nicely. This is on the following page, and there's no trick to this except you need to plug everything the right way into the calculator. But that's about it. So we have come to the end of this section, and I have a list of homework on page 919. Please do problems 7, 15, 19, 25, 27, 33, 39, 45, 53, 55, and then 59, 63, 65, 67, 69, 75, and 77. Okay, and then when you're done, I want to talk about some of them. Now, problem 15 have this problem where we have an angle 50 degrees, that's beta, and then we have one side that's 105, and then the side that faces beta is 45 unit long, and we're supposed to find the third side. Now this seems like to be a problem from the previous section, so but it doesn't matter, let's do it. Okay, and then so we need to find C, we need to find this angle because it faces the 105. We'll call it, I don't know, maybe alpha, being that this thing is beta. Okay, this is beta, so we'll call this thing alpha. Well, that looks kind of messy, but anyway, so then by the previous rules, then sine alpha divided by 105, following the law of sine right here. Sine alpha, except flipped around, sine alpha divided by 105 will be equal to sine of beta, which is 50 degrees, divided by the 45. And therefore, sine alpha will be 105 times this stuff, and we take the inverse of sine. But first, let's multiply. Okay, we'll take 105 and multiply by this stuff. And so let's do that. I have 105 times sine of 50, and then divided by 45. So I have typed in right here, and we'll see what that is first. So 105, see, I just moved this thing up here, okay, and that should give us what sine of alpha is. All right, so everything that looks okay. So that is, so sine of alpha equals to 1.7, and that is not possible, okay? There is no angle that will give you the sine value of that's more than 1, and therefore there is no solution to this problem. And so anyway, I will do more problems in the next section, in the next video.